Welcome back to the CompTIA SecurityX series. In this session, we'll cover topic 3.6.1, using Automation Security Enterprise, focusing on scripting, scheduled tasks, event-based triggers, infrastructure as code, and configuration management. Why automation matters in cybersecurity. Automation plays a crucial role in enterprise security. It helps reduce human error, speed up incident response, and ensure consistency across systems. Instead of manually repeating the same tasks, automation allows us to enforce security policies, monitor environments, and respond to incidents in a fast and reliable way. Scripting for security tasks. Scripts are small programs designed to automate repetitive operations. They are widely used for system administration and security hardening. PowerShell. In Windows environments, PowerShell is a powerful tool for managing security tasks. It can query system logs, audit user counts, check for missing patches, and even automate malware response. For example, a PowerShell script can quickly find all accounts with expired passwords and disable them automatically. Bash. In Linux and Unix systems, Bash scripts are the standard for automating system tasks. These scripts can rotate logs, update file permissions, configure firewalls, or even block suspicious IP addresses after failed SSH login attempts. Python. Python is one of the most popular scripting languages for cybersecurity. It is cross-platform and great for data analysis, log parsing, integrating with APIs, and even building custom security tools. For instance, Python can analyze firewall logs and alert administrators to unusual traffic patterns. Cron jobs and scheduled tasks. Sometimes security tasks need to run at specific times. Cron jobs in Linux and Unix. Cron is used to schedule tasks like nightly backups, weekly patching, or regular malware scans. Scheduled tasks in Windows. In Windows environments, the task scheduler allows similar automation. For example, a scheduled task could automatically clear temporary files every Sunday night or run endpoint health checks at login. Event-based triggers. Not all tasks should run on a schedule. Some should respond in real time. Event-based triggers automate actions when specific events occur. For instance, if an account fails to log in 5 times, a trigger can automatically lock the account. Or when malware is detected, the endpoint can be automatically isolated from the network. These triggers are essential for real-time incident response. Infrastructure as code, or IAC. Infrastructure as code treats servers, networks, and firewalls as code. Instead of manually configuring systems, we define them in code templates. This ensures consistency across environments, test, staging, and production, and makes changes auditable and secure. For example, using tools like Terraform or Ansible, an organization can automatically deploy firewalls with pre-approved security rules. Configuration management, YAML, XML, JSON, and TOML. Automation relies heavily on structured configuration files to define settings. YAML is easy to read and commonly used in DevOps and security tools. For example, defining CM alert thresholds in YAML. XML is more structured and often used in policy definitions. For instance, defining access rules for a web application firewall. JSON is lightweight and widely used for cloud and API configurations, such as defining firewall block lists. TOML is simple and minimal, often used for application configuration files like logging settings. Conclusion: automation in cybersecurity is more than convenience, it's a necessity. With scripting, scheduled tasks, event triggers, infrastructure as code, and structured configuration files, organizations can build strong, scalable, and proactive security environments. In the next session, we'll explore how automation integrates with enterprise-level security operations and incident response.